All right, let's take a look at speed and velocity this time. Understand what they are, what makes them different, and then take a look at how to use it. Speed and velocity are the two ways that we measure how fast something is going, or its rate of change in position. Speed is just defined as rate of change in position. How quickly an object moves from one place to another. Whereas velocity is rate of change in position, so it is speed, but it has that extra direction component on it. So speed is just rate of change in position by itself. Velocity is rate of change in position or speed and direction. So again, what we're looking at here is the difference between a scalar and a vector quantity. Again, vector quantities requiring a direction. So when you're driving down a road and you see a speed limit that says 55 miles per hour, that's a speed. That's why it's called a speed limit. We know it's a speed because there's no direction associated with it. When we're driving, let's face it, we go where the roads tell us to go. We don't go any which way we want. We have to follow the road. But there are certain situations where there are no roads, where there's nothing to follow. In that case, we need to know the direction we're heading as well. For example, flying a plane, navigating a boat. In these cases, knowing how fast you're going isn't enough. You got to know where you're going so you can make it to the next airport or make it to the port you're trying to get to. So in that case, we use some kind of directional component. You might say that a ship is traveling 20 knots or nautical miles per hour. And then the direction is not usually as simple as north, south, east, west. They'll use compass coordinates, like saying it's heading at 118 degrees. What that means is think about 0 as being east, 90 as being north, 180 as being to the west. It's heading in that direction somewhere, so northwest. But in a case like that where you're navigating a boat, you would have to know which direction you're going in order to find it to the next port call to get where you need to get to. The equations for the two look remarkably similar. Speed, the equation is speed equals distance divided by time. Sometimes we put a delta in front of the t, sometimes we don't. Don't let it fool you. That just means change in time. Where velocity is equal to displacement over time. So there's the real difference. In a speed calculation, you're using distances. And in a velocity calculation, you're using displacements. And since distance and displacement aren't usually the same thing, speed and velocity aren't usually the same thing. Speed problems tend to be a little bit more straightforward. So a ball rolls across the floor. Covering a distance of 7 meters in a time of 2.1 seconds. What is the speed? In solving problems like this, it's always best to figure out what your numbers are and identify them accordingly. Meters measure distance. It could also measure displacement, but it says distance. And 2.1 seconds measures time. Once you've done that, then identify what it is you're trying to find. We're trying to find the speed. That's our variable. Once you've identified those things, you can figure out what equation it is you want to use. And there's only one equation that has these three variables in it. Speed equals distance divided by time. Our distance is 7 meters. Our time is 2.1 seconds. Top number divided by bottom number, or 7 divided by 2.1. That's 3.3. The unit is right here. It's meters over seconds, or meters per second. That's about as straightforward as they get. You obviously have to be able to use these equations algebraically to be able to go in and solve for not just speeds, but be able to find distances and times as well. So a car travels 55 miles per hour. How long will it take to go 500 miles? Again, always a good idea to figure out what these numbers are that I've given you, what you're working with. Miles per hour is a speed unit. And we know it's a speed, not a velocity, because there's no direction attached to it. And then 500 miles. Miles measures distance. It doesn't say a distance of 500 miles. It just says 500 miles. But again, there's no direction on it. And because there's no direction on it, it's a distance. We're looking for time. Whenever it asks how long will it take, whenever it asks how long will it take, you're looking for time. Again, there's only one equation that has all of those variables in it. Speed equals distance over time. Substitute 55 miles per hour equals 500 miles over t. Our variable's in the denominator. Make sure we move it out of the denominator before we do anything. We can do that by multiplying both sides by t. We end up with 55 miles per hour times t equals 500 miles. Now we can solve it. Because we're multiplying t by 55, we'll do the opposite operation and divide by 55. Over here, everything cancels out except for t. Over here, the miles cancel out and the hours move up, giving us hours for our unit. Our number will be 500 divided by 55, which is 9.09 or 9.1 hours. If you want to turn that into hours and minutes, you just take 0.1 times 60. Again, fairly straightforward and nothing more difficult than what you'd be expected to do in Algebra 1. Where it gets more difficult in physics is when dealing with units. So let's say, instead of it telling us that we went 500 miles, let's see how far this car is going to go through a construction zone, which is 3,000 feet long. Now, what we have here is unit disagreement. The problem here is that this is feet and that's miles. We're going to have to address that. We're either going to have to turn the 55 miles an hour to feet per hour, or we're going to have to turn the 3,000 feet into miles before we can do anything. Again, I know miles per hour is still my speed. 300 feet is a distance. 3,000 feet is the distance. It still says how long will it take, so I'm still looking for time. Now let's convert the 3,000 feet to second. To do that, we have to know that 1 mile is 5,280 feet. Now at this point, we'll do a little bit of dimensional analysis to make the conversion. We start with our given, which is 3,000 feet, times and then a fraction bar. Because we're starting off with feet from the 3,000, we'll put the feet on the bottom to make it cancel. And we'll put the 1 mile on top. So it ends up being 3,000 divided by 5,280, which is 0.568. I'm going to round that to 0.57. Only unit left is miles. So once we've done that, we can replace this number with something that will actually work. I've got unit agreement now, so I can use the speed equation to solve my problem. And then from this point on, it's just the same as the one before. Speed equals distance over time. The speed is 55 miles per hour. The distance is 0.57 miles, and we're looking for time. Again, move time out of the denominator first. I can do that by multiplying both sides by t. 55 miles per hour times t equals 0.57, because that cancels over there. I'll divide both sides by 55 miles per hour. And this is where we needed those units to agree. That'll cancel out automatically, but we got to make sure that they cancel out on this side too. So they both had to be miles. That's why we had to make the unit conversion. So my units can be hours because the hours move up. They're in the denominator of the denominator. So it's 0.57 divided by 55. 0.010. So we'll call that 0.01. Now that's hours. If you want a unit that's more recognizable, you could transform that into minutes by multiplying it by 60 twice. First time you multiply it by 60, you get minutes. That's 0.6 minutes. And then the second time you multiply it by 60, you would get seconds. So it would take approximately 36 seconds to roll through that construction zone. And again, that's how we make these problems physics level. We start playing around with units and making you do some unit conversions. The only thing difference between this and a velocity problem is that you have to use a displacement with the velocity problems. So you end up with situations where you're finding the distance and displacement first, just like in the last video. So let's say a person walks 3 meters right and 2 meters left in 3.1 seconds. This is speed and velocity. Well, to do this, the first thing we're going to have to do is calculate distance and displacement. Distance is just the sum of everything. So we went 3 meters, then we went 2 meters, so the distance is 5 meters. The displacement, the delta x, is the distance from the starting position. So we started here, went 3 meters that way, and we turned around and went 2 meters that way. Distance from the starting position is 1 meter. And we would use the appropriate thing with the appropriate calculations. So when we're doing a speed, we would use the distance. When we're doing a velocity, we do the displacement. So speed is distance over time. So 5 over 3.1. Divided by 3.1. I'm going to round that to 1.6. Units right there, meters per second. Now for the velocity, remember this has to have a unit on it, a direction on it. So it'd be to the right. We're going to make sure we carry that direction all the way through the calculation. Velocity is displacement over time. So it's 1 meter right over 3.1 seconds. We use the same time for both because they're doing the same thing. They're taking the same amount of time. 1 divided by 3.1 is 0.322 something. I'm going to round that to 0.32 just because. It would be meters per second, but we also want to carry that direction over to the right because it is a vector quantity. And again, we could do the same kind of algebra with it. We can solve for distances. We can solve for times, solve for displacements. It's all the same as it was with the speed equation, so I'm not going to do any more of those.